Hello everyone. If this is your first time, welcome to Edu-Malanga. If you're joining us again, welcome back to Edu-Malanga. On this channel, we do video tutorials for the Matric math syllabus of South Africa. Today we're looking at the third unit of the year. In this unit, we will look at exponential functions and we'll also look at logarithmic functions. We're going to start by looking at the exponential functions, and this lesson is going to be just a revision lesson of everything that you did in grade 11, so I expect that you'll be able to follow with me. Let's get right into it. What we're going to do first is we're going to define an exponential expression. We're saying expression and not number because sometimes you have a, your base can be a value like a or x, and so that's an expression and not a number. Let me explain what an exponential expression is. An exponential expression consists of two parts. You have a to the power of something. We're going to choose x. So these are the two parts of the expression. This part is what we call the base, and then this part is what we call the power or the exponents. The power and the exponent put together make an exponential expression. Your exponential expression can be converted into an exponential function. And when does it become a function? When you have y is equal to a to the power of x. In that case, then you get an exponential function. Great. Now that we know what an exponential expression looks like, we're going to spend some time looking at the exponential laws. These should not be new, so you should understand them, but I'm going to explain them in detail anyway. The first law that we're going to look at is what is called the product or multiplication law. So this law, again, you have products or multiplication, which means you're multiplying exponents. So what you then have is you have an exponent, for example, a to the power of x times a to the power of y. What's very important is to note we have the same base here, right? And the product law, let me write law, yes, almost forgot, tells us that a to the power of x times a to the power of y is equal to a to the power of x plus y. So what happens when you're multiplying two exponential terms with the same base, the powers add. The second law that we learned for exponents in grade 11 is the division or quotient. It's also called the quotient law. And for this law, what happens is if you have a to the power of x divided by a to the power of y. Because we've also called it quotient, it can be a to the power of x divided by a to the power of y, because you can write this out in fraction form. What happens in this case is, again, the base is the same, so you will have a, same base, and you will have x minus y. So the exponents now subtract each other, and what you have is you have the denominator or the exponent that you're dividing by being the one that is subtracted. The third law of exponents that we should know is the power law. The power law states that if you have an exponential term, so for example a to the power of x again, and you multiply it y times into itself, what you get is that you have a, you retain the same base, to the power of x times y. So the exponents now multiply each other when you're using the power law. The fourth law of exponents that we learned is the power again, but of products. So when you have products and fractions. Say for example you have an expression a times b, and this expression is powered to the power of x. What the power of products law tells you, let me write law here, let me not forget. What the power of product law tells you is that the power must multiply each of the terms. So what you'll have at the end is a to the power of x times b to the power of x. So the power, when you have brackets and it's outside, gets distributed into each of these terms. It's important to see the multiplication here, guys. If it was a plus or a minus, it's a very different way in which you do this. And then when we're looking at fractions, so we're still looking at law number 4, but now we've got fractions. We've got a divided by b, and we've got brackets, and to the power of x. Again, we're going to have to distribute the power into each of the terms. So what we then get is a to the power of x divided by b to the power of x. And that is the power of products and fractions law. The next law that we will look at, law number 5. I hope you're following and you're understanding these laws. If you are seeing them for the first time and you're not very familiar with them, I suggest you take a blank page and you write them down as we're going so that you can have them all written down on a page somewhere, and you can always refer back when you're looking at exponents and exponential functions. So let's do the 5th law. The 5th law is the negative exponent law. So you have a negative exponent now, and what happens when you have that? When you have a negative exponent, so you have a to the power of minus x, your exponent is negative. What happens to the term is that it becomes 1 over a to the power of x. So by changing it from being a numerator and putting 1 over, you lose the negative, it becomes positive. And this is also true in the reverse case. If you have 1 over a to the power negative x, that's equal to a to the power of x. The 6th law that we will look at is the root of an exponent law. So what you have is you have an exponential term and you're taking the root of it. So for example, you have a to the power of x now, and you are taking the nth root of it. So what does this mean? I'm not sure if you know this or you're hearing it from me for the first time. But when you have roots, essentially you are powering the term by a fraction. So for example, if you have the square root of 4, that's also equal to 4 to the power of 1 over 2. Why 1 over 2? Because it's the square root, which means it's the second root. Use your calculator to check it. Now, having understood this, what will happen in this term is that you will have a to the power of x as it is, but then you'll be divided by n because of the fact that the root becomes the denominator of a fraction. And this is the root of an exponent law. The 7th and the last rule that we will learn, it's very easy, so don't stress, is the zero power law. So this is the last law, and what it says is that if you have a to the power of 0, it's equal to 1. A can be any number. It can be negative 5,000 to the power of 0. It'll always equal to 1. The only thing is when you have a power 0, a cannot equal to 0. And these are the exponential laws that we learned in grade 11. So how do you solve an exponential equation when you are given one? Again, remember we said an exponential equation occurs when you have y is equal to a to the power of x. So you must have the equal sign. But say for example you have a to the power of x is equal to a to the power of b. To solve this exponential equation in this case, it's always very important to make sure that the bases are the same. And this is what we have here. We have a on this side of the equation and we have a on this side of the equation as well. So what would that mean? Because the bases are the same, that would then mean that x is equal to b. And this is how we solve exponential equations. I'm going to end this tutorial video at this point. What we have done today is revision of the exponential laws. The exponential laws were learned in grade 11, so these should not be new to you. Join us again in the next video where we will be doing more revision. We will revise exponential functions and look at some key features of exponential functions.